Hey crew. It's not. I know it's not me. That's Groot. But here's what we're gonna do today. We're gonna do a little science lesson. So I have some stuff set up here. Okay. Now what we're gonna be covering in science is we're gonna be talking about matter, and we're gonna talk about the three different stages of matter. We have solids, we have liquids, and we have gas. Okay. We're gonna look at those separately. But today I just want to take a look at matter in general. Matter is what makes up everything around us. So whether it's the gases, the air around us, or if it's something like this table that's a solid, or even like this water that I have in this cup here, those are all different states of matter. Okay, and all matter has certain properties, we like to call it. Properties meaning just characteristics, things that are true about the different states of matter. Okay, and whether it's a solid, a liquid, or a gas, all of them have the same properties, every type of matter. Okay? First thing we need to understand, let me go get something, is matter all has mass, meaning that it is made up of particles. And so what I'm going to do is, I'm going to go ahead and bring over some stuff to show you that matter has mass. We're going to use this thing right here that's in my box. It's called a balance. And the balance here, will show us that all matter has mass. Okay? So, this is our balance, and we're going to go ahead and, Groot, I need you to move, bud. And you're going to take your little tiger with you. We'll use you guys in a second. I'm going to slide you over to the side just a little bit here. Okay? So, our balance here will show us that everything around us, whether it's gas or if it is solid or if it's liquid, it all has mass. So what we're going to do is we can use something like this. This is a mass. This is 500 gram mass. Now, mass we measure. This is not what you do when you step on a scale. When you step on a scale and weigh yourself, you are weighing yourself, and you're seeing how much gravity is pulling you towards the center of the earth. That's weight. That's different. Mass is how much matter is in you. Okay? Your mass stays the same no matter if you are on Earth, where there's gravity pulling on us, or on the moon, where there's less gravity pulling on us. We still have the same amount of mass. Okay? So that's why we use something like this. We'll put one of these on one side and something that has mass on the other side. Okay? So, Groot, can you help us out here? Good. I don't care if he says no. I'm going to make him do it anyway. Let's first of all, we're going to make sure this is balanced correctly. We're going to put Groot on this side. Now, obviously, Groot has a lot more mass than whatever's on this side. And since they were balanced, even something as light as Groot, which is pretty light stuff, he still has mass. So, if I were to take, like, say, my smallest mass here, which this is 100 gram mass, and put it on this side, I can see Groot is actually less than 100 grams. So, thankfully, I have some tinier masses. Look at them, they're so tiny, just like a little Groot here. And I can put them over here. So, this is a 50 grams. Okay, so Groot has a mass that's greater than 50 grams. Let's try putting a 20 gram one here. See if he's, oh, that's a little more. See how it moved a little bit? Okay, so he's about 70 grams. Well, that's pretty close. And if we go maybe put 72 grams, that'd be about right. He's somewhere between 71 and 72 grams. That's what his mass is. And you would say, well, no kidding, Mr. Duncan. We can see that Groot is a solid. He's there. And so obviously he has a mass. Now, what about other things? Because I said all states of matter have mass, including gases and liquids. So let's try liquids. Now, the first thing we're going to do with liquids is we're going to put this on here because we need to figure out what the mass of this solid is, because the liquid I have to pour inside of this solid. So let's get this balanced first. Too much. All right. So let's go like this. All right. Still too much. Not 60 grams. Let's try 55 grams. All right. Let's go 57. And 59. this just a little bit this way. Okay, so now we're balanced. Now what I'm going to do is I'm going to pour some water into my cup here, and then I'm going to put it back on here. Okay, so I'm going to take it off. I'm going to put, let's put about 80 milliliters of water, okay? So capacity is 80 milliliters, but let's see what its mass is. Whoa! All right, let's try this. Holy Hannah. Okay, so where were we at? We're at 50, 55, 59 grams. Okay, so I'm going to take these out of here, and we're going to see if it's 100 grams. All right, and it is. Wow, let's see if it's 200. Not quite 200, so let's put in 100, and then let's go 50. Nope, too much. Okay, let's try 120. Now let's go 140. Actually, it's 130. And then let's go 140. About 140 grams, which means we would have to take 140 grams minus the 59, and we would find that, what did I say, 140 minus 59? So that would be about 81 grams. Not too bad, right? So water, liquid, has mass as well. Okay, so we can see that on here. Now, here's the one that most of the time we kind of go, really, Mr. Duncan? Does gas have mass? Well, if it's a form of matter, if it's a state of matter, then yes, in fact, it does. So here's what we're going to do. We're going to take this baggie, and just like we did with the glass, we're going to put on here. Now, obviously, the baggie has mass. It's a solid. Okay, we're going to put it on here, and we're going to see what its mass is. And its mass is right about 2 grams. Okay, then what we're going to do is we're going to go like this. Blow this up, put some gas into it, like so. Seal it up like so. Okay, you're not going to seal very well, are you? Let's try that again. There we go. Okay. And then we're going to put that on there. Now, notice, did it move very much? Not much, but it still moved it just a little bit. And you can't really see it so well. But if I were to look at this, I would see that this guy has gone just a tinge past the line that way, which means there's actually more mass on this side. Might not be that much, but that makes sense because air doesn't have quite as much mass as liquid or solid. Okay, so it does have mass. All right, so the other thing that we can see right away from doing these different things is all matter takes space. From the air that I use to fill this bag, notice if I puff it, okay? If you have a balloon at home, you can try this at home too. Blow it up, you will see that it takes space. Those of you who play sports, basketballs, football, soccer balls, volleyballs, all those things, you fill them up with air and it gives that, it fills up the space, and especially if it starts out flat, your tires on your bike, all those kinds of different things. That shows us that gas does take up space, okay? So matter takes up space, just like this gas. Water takes up space, okay? Because it's a form of matter. And solids take up space. The way I can tell that this takes up space, well, solids, right here, if I try to walk across the room, boom, I'm going to slam into my desk here. It takes up space. So solids, liquids, gas, it doesn't matter which one. They're all states of matter. So they all have mass and they all take up space. Okay? Now, here's the other way that you can tell that these things take up space. Speaking of taking up space, this is taking up too much space, so I'm going to move this solid so we have a little more space. But wait a second. So is this just empty now? Let's check and see. We're going to bring over my green glass here, and we will see that it is full. It's full almost to the top. In fact, I'm going to put just a little bit more in here so it's right to the rim. Okay? And then what we're going to do is, Groot here is giving me permission. Groot, are you good with this? Yeah? Okay. Groot's okay with this. We're going to take his cat. Cats don't like water, but this cat's okay. Kind of needs a bath anyway. It's kind of nasty. We're going to take this cat. We're going to drop it in the... It'll be okay. We're going to drop it in the water. okay? And we're going to drop it in the water because we're going to see what happens when we drop this in the water. Now, go ahead, make a prediction. What do you think is going to happen if I drop this cat in the water cup? What will happen? Okay, possibly. Yeah, maybe. Let's see. Ready? There we go. I'm going to drop it in gently. Let's see what happens. See, and that's the problem with water, Groot. Did you see what happened? It went up, but it didn't. I didn't fill it all the way. Surface tension. Grr. We talked about that before. Okay, let's try and fill it up just a little bit more because that didn't work quite the way it was supposed to. And you know what that means, Groot? It's time for you to go in and save your little lion. Are you ready? All right, Groot's going to dive in and save his lion, his cat. He's a little worried, okay? Groot, you know what? You got a metal spring. He passed out. You got a metal spring. I'm going to drop you in there. Can we send somebody in your place? Yeah, let's do it. We're going to find a superhero to go save the day. So, here he comes. Everyone, Leonard Bones McCoy going to come in. And he's a doctor. So he's going to go in and he's going to save him. Ready? Wish him luck. Oh, look at that. Giving each other hugs before he goes. And now, Harry jumps in and... Oh my goodness. Wow, he didn't even get all the way in. His head's a little too thick, I think. All right. Well, buoyancy. Oh, wow. That is a problem. Okay. Now, notice what happened. I have a mess. Oh, man. We'll talk about this when we get to Liquid, but Liquid likes to take the shape of its container. But Bones, I'm going to take you. Can I take you out? He's wet. All right, we're going to set him there. Now notice, if you look closely here, I'm going to bring it a little closer for you. You can see now that there's not quite as much water in here. And if I were to reach in there and actually grab out my little kitty cat, which I'm going to use my tweezers to do that so I don't get my hands in there and cause more water to spill out, you will be able to see that come here, little buddy. Get out of there. I should have just done it myself in the first place, Groot. So there you go. Okay, so the solid took up the space, pushed the liquid out of the way. All right, but now that I took the solids out, notice all this space. Is that just empty space? Well, it's not. It's not empty space. Let me show you what it actually is. Here's what we're going to do. I'm going to slide this over here, and I'm going to take and put this here. Oh, man, what a mess. Okay, and I'm going to fill this up to the top. All the way up to the very, 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 very tippy top. Okay. Okay. I know it's the tippy top because it spilled over a little bit. Okay. Now, here's what we're going to do. We're going to take this. You guys ever like to, you get in trouble for that? I used to get in trouble for this when I was a kid. Now I'm a teacher. I can do it. But you take your straw and you blow bubbles in your milk, your juice, your Kool-Aid, whatever it is you're drinking. Yeah. Well, that's what we're going to do right now. I'm going to blow bubbles in here because we need to see that gas also takes space. So watch. Now, if you look, wow, it took a lot of space. If you looked, you could see bubbles going in there. And that was the gas that I was forcing into there, pushing the liquid out of the way. Oh, you just look sad. You look like you're crying. You got tears and stuff here. That's the liquid getting pushed out of the way. Now, the gas, since it is a gas, it doesn't stay on the bottom. It floats to the surface. Kind of like if you're drinking a pop and you first pour it out and then all the fizz, and then there's the little bubbles that keep rising to the surface. Well, the gas is going to keep rising to the surface. Well, guess where it is? The gas is all right here. And even when my finger goes in here, it's pushing some of that gas out of there because it's taking up space. So same thing is true in our green cup. We dropped in the salad gets taken out. Well, now the gas comes in and takes that space. So there is matter all around us. This is not just empty space. There's gas around here. Now, we're going to take a look at this as we take a look at each one, solids, liquids, and gases separately. And we're going to see how each of them, while they all take up space, they all have mass, and they all take up space, they have mass, and, oh guys, help me out. What was the other one? Take up space, they have mass, and they, duh, I don't remember what the other thing is. Take up space, they have mass. I'm gonna check my book. I gotta remember this. Maybe that was the only two things that I wanted to say. Take up space, they have mass, and yeah, that's it. Just those two things. If you can remember those two things, when we get to the different types of matter, we're going to find other things out. For instance, certain types of matter can have different colors. Not all liquids are clear, like water. Not all solids are brown, like Groot or my table. Not all gases are clear like we see here. Some gases have colors to them. So we're going to take a look at the different properties of solids, liquids, and gases. But today I just wanted you to see those two things. Every type of solid, liquid, and gas, they are all forms of matter. They all have mass, and they all take up space. Okay? Next time we'll take a look at solids and just look at solids specifically and what we know about solids. Okay? All right. So, science lesson for today.